Eric, the first thing I think about when I hear Archinaut is an architect and an astronaut. Is that what you were going for?
Yes, you're absolutely correct. That's exactly what we were going for.
So what is Archinaut?
So Archinaut is a suite of capabilities for in-space manufacturing, robotic assembly, and verification and validation.
So what type of in-space manufacturing are you trying to do with Archinaut?
Well, we think that Archinaut could be used to build any large structure in space. It could be a structural backbone for a space station, it could be a large RF reflector or communications dish, it could be a telescope, or it could play a role in our journey to Mars.
Now, why would you want to build structures in space?
So most structures that are designed for space have to survive the launch environment. So when you look at how long something's going to operate in space, it's designed for an environment that lasts for a very short period of its total lifetime. So by building and manufacturing these structures in space, we can design the structures to survive the loads they're going to see during operation instead of during launch, which means the structures can be lighter and we can save on mass sent to space.
Now, the Archinaut is basically a 3D manufacturing machine that can put structures together in space. How different, or is it different than, your off-the-shelf 3D printer?
So Archinaut is a little bit different from a traditional 3D printer. Most traditional 3D printers are limited in the size of the object that they can produce. Things that come out of a 3D printer are smaller than the 3D printer itself. Well, when we were looking at Archinaut, we knew that we needed to build a system that could build structures larger than itself. So we took a typical 3D printer, we made some modifications to make structures that could be indefinitely long in one axis. So for example, we could produce a structure that's 500 meters or a kilometer in length. And so that's something you could never do with a traditional 3D printer.
I see that you actually have a structure in your office that's pretty long that was made with a 3D printer. Can you tell me a little bit about it?
That structure was produced by our Extended Structure Additive Manufacturing Machine, or ESAM. And that's the mechanism that we put together to make very, very large structures. So we did a test in our office. We set up the printer and we manufactured a continuous structure that was 37 meters in length. And so to give you a little bit of scale, that's about the same length as one of the solar arrays on the International Space Station.
How long would it take for Archinaut to construct a structure like that?
So it really depends on how large of a structure we're building and how large the Archinaut is that is building that structure. So for a typical structure like a space station backbone, for example, or a big RF reflector, it could take anywhere from a few weeks to a month or so to build it, which kind of sounds like a long time, but we like to think of it in terms of the life cycle of what's being produced. So if we started at the same point and built something on the ground, manufactured, tested, then waited for a launch before ultimately deploying it in space, we think that even though our manufacturing process is a little longer, we can get it there faster.
I see that in your facility here, you have a full-scale mock-up of an Archinaut spacecraft bus. Can the Archinaut bus be scaled to size based on the mission?
Yes, absolutely. One of the things that is flexible about our 3D printers is that we can scale them based on the size structure that we need to produce. So the bus that is in our office is meant to produce something that's maybe about a foot or so in diameter and can be almost an indefinite length. If we needed to make something that was 3 feet, 6 feet, even 10 feet in diameter, we just simply take the components that we have, scale them up, and then we can use the same architecture that we have currently to control and manufacture the structure. So the system is very scalable based on what we're producing.